continuing where we left off the other day. So we're going to just kind of start at the top, 7.3 continued. We're still talking about integration by parts. And I've got some other examples I want to show you on what we're going to do today. So we're going to start right off with example number 1. And this is what you're going to be asked to do for numbers 11 through 15. The directions are going to say solve the initial value problem. The initial value problem is when they gave you an x and a y and asked you to solve for c. So we're integrating, plugging in x and y, finding c, and then putting c back in. That's what we have to do. Okay, so first of all, it says dy dx equals 2x e to the negative x. Now when it's written this way, it's really because this dx right here, I can multiply that over to this side, right? So then you can see we can integrate it. So I have technically dy or y prime equals the integral of 2x e to the negative x dx. So now, do we want to do it by parts or do you want to do it the tabular method? Tabular sounds good. Okay. So we have 2x, 2, and 0. Over here, we have e to the negative x dx. We then have, remember this would be our u substitution. Du is negative dx, so the negative comes over here, right? So this would be negative e to the negative x, and then this would be positive e to the negative x. Going in our two directions, positive, negative. So we have y equals 2x times negative e to the negative x, that makes it a negative e to the negative x, then minus 2 times e to the negative x plus c. Okay? Then, of course, at the beginning, it's going to tell you that y equals, let's say, 3 when x equals 0. So this is where we plug the stuff in, find c, and then we back substitute. So 3 equals negative 2 times 0 e to the 0 minus 2 e to the 0 plus c. This one all equals 0. I'm just going to cross that out. Negative 2 e to the 0 equals what? Negative 2 plus c. Adding 2 to the other side, we get 5 equals c. And now we're going to substitute that back in for c. So our final answer will be y equals negative 2x e to the negative x minus 2 e to the negative x plus 5. We're good there? Okay. So you just have a couple problems like that, but I wanted to clarify the directions, what the directions meant, what they were trying to get you to do, okay? All right, example number 2. This will be in the next portion of the assignment, which will be 17 and 19. It says to use parts and solve for the unknown integral. So let's say I have the integral of e to the negative x cosine x dx. So you'll notice on this one that neither one of those have a derivative that will eventually drop out. It's going to go over and over and over and never finish. Okay, so I need to show you what the trick is when we get problems like this. All right, so first we've got to decide our u and our v. So we're actually going to use the e to the negative x as our u, and this will be our v, or our dv, excuse me. Alright, so I have u equals e to the negative x, dv equals cosine x dx, du is negative e to the negative x dx, and my v is sine x. Alright, so let's write down what we have. So I have this integral, the integral of e to the negative x cosine x dx equals u times v, or e to the negative x sine x, minus the integral of v sine x du, which is negative e to the negative x dx. So now I personally like to take this negative out to make this a plus. You guys okay if we do that? So let's make this a positive here. So you can see we're going to have to do it by parts again, right? Okay, so let's do that again. This time we're still going to use our u as e to the negative x, and our dv this time is going to be your sine x dx. Plus u. Alright, so du equals negative e to the negative x. Our v is, good, negative cosine x. Alright, so I'm going to have the integral of e to the negative x cosine x dx equals e, maybe, come on, catch up, to negative x sine x plus u times v. So e to the negative x cosine x, or sorry, negative cosine x. So I have e to the negative x, negative cosine x. So I'm going to change this plus to a minus. You guys are all right with that, right? And then minus the integral. Get that out of my way. Minus the integral of v, which is negative cosine x, du, which is also a negative. Those two negatives together are going to become a positive in our integral, okay? So I have e to the negative x cosine x dx. Are we all good with that? So what do you notice about that integral I still have hanging out down there? It's exactly the same as where we started, right? So what we're going to do, the trick to this, is we're going to add this integral to this side, because they're the same, right? Alright, so I'm going to add this integral to this side. So I actually am going to have two of these. Let me move that up a little bit so you guys can see. So I have two integrals of e to the negative x cosine x dx equals e to the negative x sine x minus e to the negative x cosine x. We're still good? So then the last thing we can do is we're solving for this integral. We can divide both sides by 2. Divide by 2. We're going to divide this whole side by 2. And then put plus c on the end. So that's going to happen every time that neither function will drop out. This will happen every time, where eventually we'll get back to what it was originally. So you can add that integral to this side and then divide over. Okay, and you can either put underneath 2 underneath the whole thing, or sometimes this book like writes 1/2 in front of each of the terms. Same either way. Alright? Okay, we only have a couple of those in your homework, but it's still, just in case. Alright, example number 3. I only have 2 examples to go. Example 3. This is from numbers 21 through 23. And this one says to use the tabular method. Use the tabular method, to find the antiderivative All right. When we find the antiderivative. Thank you, Mr. Dean. Good. How are you? They're working so hard in here. All right, so we're going to use the tabular method here, right? So what part of this is going to be our u, or our derivative? Good, x to the third. So the derivative of x to the third is 3x squared. Derivative of 3x squared is 6x. Derivative of 6x is 6. Derivative of 6 is 0. The other part, the cosine 2x dx. Now we're going to have to do a u substitution for 2x, which means our du is 2dx, and we're going to divide by that 2 to get rid of it, right? So each one of these will have, again, a multiple of 1/2 in front. All right, so antiderivative of cosine 2x. Positive sign, right? 2x with a 1/2 in front. Okay, so then antiderivative of 1/2 sine 2x. Good. Negative 1/4 cosine 2x. Antiderivative of negative 1/4 is going to be negative 1/8 sine 2x. And the last one then. Antiderivative of sine is cosine, and it's a negative, so it makes this a positive 1/16 cosine 2x. 2x. All right, so again, we like to draw these. This is going to be a little bit longer one than we've had so far. Of course, positive, negative, positive, negative. So let's put this whole thing together. So we have x to the third times 1/2 sine 2x. So x to the third, 1/2 in front, sine 2x. And the next one, we have 3x squared times a negative and a negative. So the two negatives become a positive. 3x squared times 1/4. I'm going to put the 3/4 x squared cosine 2x. So then we have 6x times negative 1/8 is going to be a negative 6/8, or 3/4 sine 2x, minus, I'm going to have to go to the next line here, 6 times 1/16, or 3/8 cosine 2x plus c. Yeah. Oh, the 3/4 this one is. This one right here, yeah, there should have been an x in there. You're right. I left out my x. Thank you very much, Ryan. Anybody else? Any questions at all? It's just a little bit longer than what we've done so far. Okay. And then the last section we're going to do, 29 through 31. Last example. Example number 4. 29 through 31. And then the rest of the problems, there's an application one, and then there's a couple multiple choice ones at the end of that assignment. Okay, multiple choice are similar to what you might see on like the AP test, so I wanted to start including some of those. So in this one, the directions are going to say solve the differential equation. And this one is written as dy dx equals, I'm going to go with x secant x tangent x. Just to throw it up there. Throw one more up there. Alright, so again, technically this dx multiplies to that side. So we have dy equals x secant x tangent x dx. Then really what we do is we integrate both sides, is what's actually happening, right? This becomes y equals, and we're going to integrate that side. So we can choose our u and v, okay? We're going to have to do that here because what's left, we can do an antiderivative, but how many antiderivatives can we do? It's going to stop, right? So we've got to do this by parts. So we have u is going to be x, dv is going to be your secant x tangent x dx. So du is simply dx. RV, antiderivative of secant x tangent x. Secant, very good. Alright. So u times v. So x secant x minus the integral of v du. Secant x dx. Now, I brought this one up again just because, and you guys probably won't see it on the AP test at all, but I do want you to be aware for future knowledge. We had one of these back in 7-2, and it gave you that we should multiply this secant x by secant x plus tangent x to both the top and bottom. Do you guys remember when we did that? Yeah, so we're going to do that here. Didn't want you to forget about that wonderful little hint. So, we have x, secant x, minus the integral. If I distribute on top, I will have secant squared x plus secant x tangent x over secant x plus tangent x dx. So then we had to do a u substitution. What do we do a u substitution for? We usually use the denominator, right? This will be our u. So if u is secant x plus tangent x, our du, derivative of secant x, is secant x tangent x plus derivative of tangent x is secant squared x. So all of a sudden, if you look back here, this piece right here is our u. This whole top is our du. So we have x, secant x, minus the integral of 1 over u du. So I have x, secant x, minus, what's the antiderivative of 1 over u? Natural log. And then we put the absolute values. Our u, we said, was secant x plus tangent x inside the absolute value. And what do we put at the end? Plus c. I chose this one just because it was harder. Everything else is easier than this one. Okay? Alright, you guys want the rest of the time to work? Alright, sounds like a plan. As Trevor's yawning over there.